So guys, it's time to see how we can use particles to create some real-world particle effects. So the first thing we are going to check inside chapter 5 is to disintegrate the mesh and to create sparks, because both can be a really nice effects we can add to our shots. So we have a simple scene. You see, we have essentially a grid with an extrude volume to have this kind of proportion, and then we have the outground. It's just an out node to be able to pick the output from this network. Then we have the emitter shape. Actually it's called emitter shape, but we'll see later how to use it. And we have essentially a sphere that is scaled, and then we have a UV projection set to polar. Then we have the animation. Animation is done essentially with an expression, so we have string t multiplied by 150, so every seconds we have 150-degree animation over the z-axis. Actually we have a translate, so it's moved up, but we'll see later how to animate this one. And then we have just a UV kick shade just to see this map, to show the UV, just to be able to see in a better way the animation. So essentially the scene is really simple. What I like to do is moving the sphere, and when the sphere is touching the ground there, we are going to create some kind of sparks. So let's go to see how we can do something like that. Essentially we have to create something else, so we have to create the real emitter. So let's say that we have a new geometry. Let's say that this one is the shape, but this one is the particles, sparks. We need an output node there, so we can connect to the output. So that's out sphere, and we go for the shape. And about the color, let's go for red. So inside this one we can say hide the other objects, and then we go with some object merge. So this one will be merge ground, Ctrl C, Ctrl V, and then we have merge sphere. The first one is going to pick the ground output, and the second one is going to pick the out emitter. Okay, so now we can start working on this kind of object. So we like to do something really simple. I'm going to use a color. So in this way I'm going to color in a different way both. Let's call it color sphere, and we go to, oh sorry, this one is wrong, so Ctrl C, Ctrl V, and this one is color ground. In this way we are going to transfer the color between both meshes, and it will be the best way to create the animation, okay, the emission. So our ground will be black, so we go to have also the color there, so it will be simple enough to choose which is the color we are going to play with. And then about the other mesh, we are going to color it in a different way. And then the second one will be red, so we are going to use a red color. So we have this color over this one, so the objects are a little bit different. So by the way, if we go to check the properties there, let's go inside the geometry. You see that we have the CD for both, so we have the possibility to transfer the color when the objects are touching. So let's go to use an attribute transfer. Okay, so we like to transfer the red over the ground. So the first one is where we like to transfer the attribute, and the second one is where we like to transfer the which one we like to pick the attribute. So that's essentially really simple. Let's go to see the condition, and we like to change the distance threshold because it is going to use let's go to see the ghost, the distance between both, and actually it's set to 10. If we go to 1, you see that it's going to have a better simulation. By the way, let's go over the ground, and over there let's say that we like to have more details, and back again there. Okay, so you see that now it's better than before. So 1 meters is too much. Let's try with 0, 1. So we are talking about 10 centimeters. So let's go to have a new transform to animate. So goes down. And our animation will be a translation, so over the y-axis. So we say that here we have a key, and then we go to the key number, maybe 40, and we go down. That's right, because we are not able to see how this looking. So now we see how this working. Sorry, it's this one. So give me just a second. It will be better to work there, and then we work with this one, and we say that we like to hide. So this one is picking the right one. Let's see the object. Okay, so this one is the right one. Okay, so let's go back there, and let's say that essentially it is here. So let's say create a key. So what we have is that you see this rotating, then it goes to touch, and maybe we'll have maybe until 100 we have the same key, and then we go up again. So something like that. So you see it's like that, this going there, it is touching, and then it is moving forward. Okay, so back to the attribute transfer. We see that it's moving, and now it is touching. It is essentially a little bit too much because you see this distance, so we have to have a better control there. So let's try with 0.5, maybe 0.2. Let's see when we touch. Okay, so you see that we have it just where we have the sphere touching. Maybe we can have, this one is nice enough. We can have essentially maybe a little bit more detail again there. So let's say 100 and 100 and back there. So you see that it's a little bit better. It is nice enough, but I like to have a little bit of blending. Maybe that's too much. Okay, so we have a little bit of blending. It's not so precise, you know, so you can create something more complex, but it is just to understand in a really simple way how it works. Okay, so Control S to save. Now we have the right animation. So, you know, in this way we have an area. So let's say transfer CD. So we are moving the color from one to the other one. And now here we can have a scattering. So we can use the scatter. And let's say scatter points. With this tool, we are going to scatter the points just where we have the right color. So let's use by density, and let's say density attributes is CD. And let's go to remove the force value and all the other information there. So we should have particles just when it is touched. Okay, let's go to have a really higher scaling. Okay, so you see that it's creating points in this way, just where it is going to touch. Okay, that's nice. So we can start creating particles. So there we can have our pop network. We can go with a pop network and then we can add more stuff. And let's call it sparks. Now we can go there and seeing how the sparks needs to work. So let's try to make some basic configuration there. So we say where we have the particles, so you see that the particles are there. We say to use essentially points. Let's remove the guide and we say to use the first context, and then about the bird, let's say that is enough to do something like that. So we'll see later if we have to do something else or not. Just to be sure, we need a speed because actually we have no velocity, so nothing is done actually. So I like to create some velocity there. And to create the velocity, let's see the normals. So you see that there we have all the normals going up, then we have the scatter points, and then let's see there we have nothing. So let's try to move the data from these attributes to the other. So to do something like that, you know that there we have essentially the position and then we have the color. So something I like to do is to create the normal for this point. So we go to use the points, that's an attributes, and let's create n, that stay for normal. So let's go there, and you see that with this one we have the normal visualization. So let's say that the attribute class is point. We say let's create the normal. So you see that now we have the normal, and we say that we are going to use the constant value. So add constant value, and let's say 1. So you see that now the normal is going up. So in this way we are saying that the particles will go up. But to do something like that, you know, now we have the normal, but that's just the normal. We have to convert this one to a velocity. So let's go for an attribute wrangle. Let's say convert n to v. With this one we are going to convert the data we have. So it's the at v velocity equal at, that stay for attributes, n, and then that's done. So now you see that we have also the velocity, and the velocity is equal to the normal. What this means? It means that now we are able to move the particles with the right velocity we had before. So let's remove the normal. Let's go there. Let's see what happened. Okay, you see that the particles are flying up. Okay, so let's go inside, and essentially it's that, you know, inside the attributes is using the inherit. We can say that that's okay. If we like, we can have more variants. So we can say add to inherit velocity. In this way you see that the particles are flying away in all direction with no velocity because we are adding nothing, but we have a variance. Okay, so it's using the up vector to move the particles, and then we have also the particles with a variation all around. Let's go to have a gravity. With this one we have the particles falling down. Okay, you see that, so it's moving up and then goes down. Okay, so then something more, something else that can be done is to have, for example, the ground plane, to have the collision, and we have also a merge. So we have this one, and then moving there. So we'll have the collision with this one. Okay, you see that it's colliding. So something that can be done there is to have an higher velocity. Let's see, for example, with 5. You see that they are moving really fast. Let's go for 2. Okay, that's not bad. We can add a little bit of drag, so pop drag. Let's go inside pop drag, and let's call it higher drag. Let's try with 1, nothing special. Okay, so it's just a little bit. Something that we can done is to go there, and inside the geometry, let's say that the particles are bigger, so we see stuff in a better way. We can have a pop color just for the moment. So with this one we go to have this color like sparks. So we have the particles flying up and then they are touching the ground. Okay, so we can go back there and essentially the scatter points, let's try with less particles. Let's try with less points because we have less points. So I like to have more points, and inside the particles, let's go in the bird, and let's say that we have less particles created. Okay, so you see it is going better. Maybe we can leave this one and then we see if it is enough. So we have particles flying away. Let's say that the life expectancy is just 2 seconds with a variance of half seconds. So particles are flying away and then they will die. Okay, nice. So what's going on there? We have these parts there. We say to see just the pop objects, so we see just the particles. And then we go to have a new object. We can use the same, so let's go to have a merge just to see everything, or maybe we can just say let's show all objects. Okay, so what we'll see is that no, because you know this one needs to be not visible, so let's say that the emitter shape, this one is not visible, and then we go to have an out. Okay, and this one is named out anim sphere. Okay, so there we can have a new geometry sphere, and there we can have an object merge. It is just a way, so merge anim sphere, and then back there we say to go to pick the anim sphere there, so inside the particles. Nice. So now we should have Let's see the particle. So now it should work. Okay, you see that we have the particles flying away in this way. Okay. It is working. Let's go to save. Okay, so we have the sparks. We have the basic information about the sparks. Just to see the points. Okay, let's say that we see just the particles. Okay, we have this kind of velocity there, and then we have this one. If you like, we can have a little bit of randomization just to have different speed, and we can do this one before the conversion. So we can have an attribute randomize there, and let's call it random n. So what's going on there? Actually, it's going to random the color. So you see that we have different color, but in this case we have to randomize the n. So let's see. You see that everything is randomic in a really strange way. So let's say that maybe it's nice enough, but we have to see the particles, how it is looking. Okay, it seems not bad. Let's remove the normal, and over there, let's say that we'd like to have more speed. Okay, we have enough chaos. That's not bad. Okay, so we have a little bit of drag with a speed there, and essentially something more we can do is to have some more chaos in the animation. So we like to have a little bit of wind, nothing special. So let's say that there we have another pop force, wind and chaos. Okay, we go to minus x. So let's say that here the force is minus x. So we should see the particles, let's say minus 10. So we should see, okay, you see the particles are flying away. Let's say maybe minus 2. So you see that the wind is working. And let's see, okay. And about the amplitude, let's go for 1.4, and we should have a little bit of chaos. Okay, and maybe a little bit of smaller scale for the chaos. Okay, nice. So we should just say, okay, let's go to have more particles. So in this case, you know, it is working really nicely. Okay, save. We need a material, so let's go to have a principal shader, and this one will be called sparks. Let's go back in the object, and we say that the particles, this one is not visible, and this one, the sparks, give me the time just to understand what's going on. Here we have just the pop objects, and that's right. Okay, we'll see later what's going on. Let's try just to use directly a null. Okay, That's a better solution. So let's go back there and let's going to call this one. Okay, so this one is removed, and then back there. Okay, it works perfectly. Okay, nice. So we have this kind of sparks. You see that they are flying away all over. We need to render this kind of stuff. So a new camera, let's lock the camera. And about the output, let's go, okay, for example, there. And the particles has the right material, so material sparks. And we have to take care about the rendering in a few. So render view and render. Okay, it needs a little bit of love, so let's go to a light, and this light is set to 0.1, so just a little bit of lighting. And back in the material, okay, surface, let's say that we are not going to use the point color, so we use just this color. Let's say that's the color, and then we go inside the emission, so we don't need this one, so we can take care about the color essentially from this area. So we have the emission, you see that we have lighting done by the points, and let's say that this one is maybe 10, so it's really high. Okay, back in the output, we have to take care about the scaling there, so the object, sorry. Okay, in the particles parts there, we go for point scale to 0.1. So you see that we are talking about really small scale particles, and that's nice. And about the output there, let's go for the rendering, and let's say that we have a physically based rendering. Then we need to have the motion blur, because in this way it's not so simple to say that this one is something related to sparks. We have motion blur, but you see we have no blurring, and that's due to some settings. So we have to go there and say use the velocity blur. Okay, we are starting to create sparks. Let's go back to the sparks material, and let's say that's higher the emission, so we'll have a nicer look. Let's go for something more orange, so we have some more yellow color, and then we have a really nice coloring. Okay, if you like to have a better quality there, you have to go inside the output, and then you have to say let's use, for example, 6 and 6 in the pixel sample, so it will be more refined because we have the motion blur. Okay, it's slower to be calculated, but it is working in a better way. So stop and back there. So we have a better look than before, but I like to work with a collision, because actually, you know, we have the particles that are colliding. Let's go inside. Okay, they are colliding, but then we have still particles moving over the ground, and that's not right. Okay, so we have to say that the particles do something. We have the collision behavior inside the pop solver, so we have to say what's going on when we have the collision, and we say let's add the heat attribute. In this way we have the attribute about the collision, and then we say that let's use a color for the heating. So if the particle is colliding, it will become red. But our main problem is that, you know, we have a pop color. So let's remove the pop color. Actually it's red, so it's not working. Let's say that when we have a collision, we have the particles going to green. So let's see. Okay, you see that the particles are colliding and becoming green. And that's nice because you are able to know if the particles is colliding or not. The response to the collision will be a die, so the particles will die as soon as we have the collision. Okay, in this case we are going to move all the particles that are colliding in a new group. So collide group, let's call it colliding particles. Nice. So if we go back there and we move later to something else, we are able to see that we have something new inside the particles. And for example, we can have let's say maybe we have a color. Okay, you see that there we have some information, but the nice information is that let's try to search for colliding. Only show selected colliding particles. So let's double check if we have the group. The group is there, but we have nothing inside. So let's go back there and let's say that the particles will not die. Let's say that we have a stop. So let's go back there again. Let's go to a simulation. Then back in the I key, you see that we have the particles. So that's why before we had no particles. Okay, so let's go to see just the particles that are colliding. Okay, so let's remove this one. Let's say that we show everything, and this one is removed, we don't need it. Let's go back there and let's say that this kind of particles will die. So I like to do something else when we have this kind of effects. So when we have the collision, I like to create new particles that will goes up again. To do something like that, we can use a really nice node, and we are talking about, sorry, this one is connected, the pop replicate. This one is able to create new particles from the particles we have now. So you see that in this case, we have particles created all around the other particles. Okay, so that's not right. By the way, let's work with a low amount of particles, so we should have something like that. So we have, let's see what's going on. We have just one particles and flying away. So something really simple. Let's go back to the pop replicate and let's try to see what's going on. Okay, we have the particles created since the beginning, and that's because we say to create particles with a replicate. So replicate collision. Okay, so we have to say to use a group, and we are going to use the colliding particles. So if we go back, you see that we have essentially the standard particles, and then we have something that is created when we have the collision. That's the particles that we created with a collision there, so we have to take care about it. So it is essentially like another pop search, so we have to take care about it. Let's say that we like to have a lower density, so you see that we have less particles. You can try with 200, it's not a problem, you can find the one you like. We can have a lower life expectancy with a lower variance, so these particles will die faster than the previous one. And then shaping. Shaping is the space around the particles that is dying. It's going to fill up with some new particles. So you see that the shape can be a sphere, a box, cylinder, and stuff like that. So you can go to control the shape there with the sphere or the stuff you like, or maybe you can control the position and the size, so everything can be tweaked. Let's say that we go for a smaller scale, so you see that the contact point is really near where we have the collision. Okay, so you see that's what's going on. Let's try maybe 0.35. So just a little bit bigger than before. You see it there. Okay, we need to control the we have also noise, if you like, there. So we have the possibility to control the shaping with the noise, but it's based on the shaping, so you can take care about it. Let's go in the attributes because we like to have the speed. So actually we have no speed controlled. Let's go to say, okay, let's inherit everything about the attributes and let's add the velocity. So let's go to use this kind of velocity there. Okay, you see that now we have this kind of splashes. It means that, for example, if we say 10, let's go there. You see that we have a really huge speed. I narrow it. Let's go to have 1, that is enough, I think. Okay. Okay. And let's say that we have also a radial velocity. Let's try with an higher one. Okay, you see that we have this kind of explosion all around. Okay. Something that can be done is to add also the possibility to have, maybe we can say, okay, let's move more up. You see, so we have more the effects of something popping out. You see, okay. So maybe that's too much. Let's go with 1. And let's say that the variation is 0.5. Let's go for 0.5 and 0.5 also there. Okay, that's not bad. If you like, you can have more speed and velocity also over the others. So what this means, it means that you see we have something that is popping around all around there, and that's really nice. So we have essentially everything simulated. Just to see something more interesting, let's go to show everything. So that's the scale we have there. So okay, just to have something better, we can go to have the collision with the right meshes. So let's say that one collision is with the ground. So this one is a static object. So everything is done inside, you see. So inside the particles, we should have everything set in the right way. We have just to take care about this one. So let's remove the ground plane. So we'll have the collision. Okay, let's say that we have this one and the stuff are removed. So that's what we have. Let's see if it's still working nicely. Okay, so obviously if the particles are going out of the table or the ground, obviously we'll have some kind of different collision. Okay, so if we go to render this one, obviously it's perfectly working. So it is working. Maybe we can have a smaller scale. By the way, to control something like that, we can do a really nice trick. So we have the sparks. So we have the particles goes out of there, and if needed, we can change the P scale because we are going to use the P scale as a property. Let's go there. Here we have no P scale, but we can create it. So let's say attribute randomize. So we have some sparks that are bigger and some sparks that are smaller. So random P scale. Okay, so let's go to create this one. Essentially we can erase there and say p scale. It's obviously related to points. We say that we are going to set the value, and we go to see what's going on in this way. So let's see when we have the particles. P scale is there. You see it's randomized. So let's go to render and we see what's going on. We have two particles. We have three value, and that's not right because it's just essentially a point. We have just one dimension. So we are going to use just, because in this way it's going to scale over more axes. It's not the best way. By the way, we can do it. So let's try with just one dimension. So in this way we have just a p scale. So one is big and the other is really small. And about this one, so let's stop there. Okay, so copy and then there. This one needs to be stopped. Okay, we get to use the same. So we can copy this one and use the same and use the same. So everything is connected and we can use the same value. We can do the same there. So copy parameter and then paste relative. And we use the same, Ctrl C, Ctrl V, and Ctrl V. Okay, so let's say that the scaling can be between 0.05 and 0.2. Okay, so we have two different scaling. We should have something that is better than before. And this one is working over everything, all particles we have there. Okay, so you see it's working. Just to be sure, we are going to use a nice scaling. Let's go back. We should have 0.1 before we had, so 1 is really big. So let's go back there and let's say that the maximum value is 0.1 and the smallest one is maybe 0.05. Okay, let's go for a smaller scale. Let's say maybe 0.02, 0.05. Maybe this one can be smaller. Let's try to re-render, and it should work nice. So the other thing we can see is to have more particles. It is rendering now. Okay, you see they are small enough. Some are smaller and some are bigger. Okay, so let's close. What we can do, let's think about I think that's all, because it is working nicely. I like just to change the collision. So actually we have the collision with the ground and that's done in the right way. I like to create the collision with the sphere too. So this one is really big. So let's go there and let's say it is picking this one. I mean, let's go there and the object sphere is picking the out sphere there. So we should have a transform, or maybe we can directly have a lower scale there. Let's say 2.5. So let's see if it's able to go down. Hide other. Okay, the scale is right. Let's go in the sparks. Let's go to see if we have the transfer. This one is set. Okay, let's go there. So it's not picking anymore down, so we have to change the animation. So let's go there, shift key, let's say -0.6. Okay, maybe it's too much. Let's try with 5, 2, 4, 5. Okay, so now it is touching in the right way. Okay, so let's go back to see if it is working in the right way. And then we have the point, random point. Then let's see the sparks. Okay, it seems working. Okay. Okay, the others maybe needs to go a little bit slower, so let's say that there we have maybe 3. We have a better speed, you know. Okay, so let's see with more particles what's going on. Let's try 50 and let's go. Okay, you see that it's working in a better way. Maybe I like to have more at the beginning and then in the pop replicate, let's go lower. So we should have less particles at the beginning. Okay, let's try with 25 there and maybe 350 there. So we have a little bit less particles at the beginning. That's nice. And then we have the others. Maybe now we can have a little bit more speed. So in the attributes, let's say again 1. Okay, so for example, if we go to render this view now, so you see it's working nicely. Maybe the last thing we have to do is essentially to have smaller scale particles, so we can have something like 0.05 there, maybe 0.03 there. We had no random scale set to 1, okay, so don't worry about it. So you see it is working in a really nice way, and so something else can be done is to have the collision with the sphere, and to have the collision with the sphere we have this one is the one that is rendered, so we can say to this one, let's go for static objects. So back there, let's go to see what's going on. Let's go in the particles and let's say that this one is not active. So we see if we have collision with the sphere and it seems right, but it was wrong. So what we have to do is to say that this one is deforming because it is animated. So let's say, okay, that's deformable, and then we should have the right collision. So let's go to double check if everything is working nicely, and it is working. So we have the collision with the sphere, and let's see what's going on when we have both collision. Okay, so back in the pop replicate, let's see if we go to have 0, so we have no speed, I narrow it, so we have just, you know, the radial velocity, so it's less energy than before, maybe it's better. Let's try just to have a little bit of velocity. It's not bad, I think, maybe just 10%. So let's go back to be a little bit near the ground, so we go to move, and let's see what we have inside the render. Okay, that's the result. So maybe we can just have more and more particles, and to be sure that it is nice to be visible inside the viewport, we can go a little bit lower there, and we say that pop replicate is able to create more sparks, sub-sparks during the splitting. Let's go up. So, okay, you see that we have a lot of small sparks created by this one, maybe a little bit less. And then we say that we like to have more sparks at the beginning. Let's remove this one just to double check. Let's go up. So if we go at this frame, I like just to be sure that everything is working really nicely. It is not bad. I like maybe to have still a little bit more particles, and it depends on the point there. So let's say maybe we have double points. And then there about the number, let's say maybe 250, so we have a huger number of particles that are created. So you see a lot of sparks. So let's go to see this frame. So the amount is nice. Obviously the scale is big because we are inside the pop network. So I like just to double check what happens when we have also the pop replicate. So let's go back in there. The pop replicate is set to on. Okay, I think we have a lot of particles, so maybe let's go lower. There. It takes just a little bit to, obviously, to calculate the particles. It is still too big, maybe. And maybe we can have no speed and less speed also there. So again, let's go to see how it looks. Okay, I think that's better. So let's go back to see how it looks in rendering. Okay, that's not bad. Obviously, if you like to have an higher quality of rendering inside the mantra, you can rise up the pixel sample. If needed, you can have a lower noise, and you can take care about a better GI quality. That's not so important for our purpose, so we can do just a simple preview. So Control S, so I'm going to create just a rough preview for you, so you will be able to see how it is working. So guys, just made a render test. So let's use the image viewer to see how it is looking. So give me just 2 seconds to load everything. So inside the render folder. Okay. Done. So that's the render. Let's go to play. It is loading in RAM. So you see that it is working perfectly. Maybe if we like, we can have a little bit less bouncing, maybe. So a little bit less energy when we have the collision. So that's the only thing I like to take here. And you know, if you like, you can have also the depth of field, because it will be nice to see something like that. So if you have to fix this problem, we can go inside the particles, and inside the sparks we have the pop replicate, and there we can say to have a little bit less velocity. So for example 1 for this one. Let's go up to 1, and it should works in the right way. So let's go back there, let's say 150. So it is going to simulate everything, you see, step by step. It's done. So let's go for real-time playback, and let's go to see. Sorry, there. Okay, we have less bouncing, and that's better than before. Maybe just to have something more interesting, we can imagine to have, give me just a second to see how it is looking. I think it's not bad. Maybe just a little tweak. Maybe we can have a little bit again back of inherit velocity, and then we go less up and we go more in the radial velocity. So we can do it step by step. Okay, so we have less bouncing up and more with a radial speed, and that's all. Okay, so that's done, guys. Next step will be using this setup. We are going to disassemble part of this mesh. It will be simple enough to be done with the actual setup. So let's move forward for the next.